Hello everyone, my name is Madhura Devshetwar and today I am excited to present my final internship project, the Smart Factory IoT Monitoring and Control System. This project is the culmination of my work in embedded systems and the Internet of Things, focusing on real-time industrial supervision. Before we dive into the project, let's define the foundation. The Internet of Things or IoT is a network of physical objects embedded with sensors and software. It allows these things to collect and exchange data. In an industrial setting, this means we can monitor high value machinery and environment conditions without human intervention. Problem statement for our project: in modern factories, manual monitoring is a major bottleneck. If a machine vibrates excessively or a warehouse becomes too humid, human error often leads to delayed responses, resulting in equipment failure or inventory loss. My project aims to solve this by providing a 24 into 7 automated monitoring and remote control solution. Let's look at how the system is built. We have perception layer consisting of two Arduino nodes. These nodes communicate via a network layer using the MQTT protocol over Ethernet. Finally, at the application layer, we have the ThingsBoard cloud platform, which acts as our central command center for visualization and control. Our first node focuses on the production line. It monitors temperature, humidity, and machine vibration using an LM35 sensor and a potentiometer to stimulate vibration level. This node is critical for ensuring that manufacturing machines are operating within safe thermal and mechanical limits. So these are the node 1 and node 2, that is production and warehouse respectively. Node 1 is focuses on machine health, monitoring and vibration level, focuses on security, access control and inventory climate. Production line health, node performance matrices, automated safety thresholds. This is centralized visualization, which is automated alarm management system, interactive switches for RPC or actuator control, time series charts for vibration analysis, real-time gauges for temperature and humidity. Core logic and network layer statement. Let's look at the implementation for Node 1. As you can see here in the code, I am using the PubSub client library to handle MQTT communication. A key part of this code is the RPC MQTT callback function. This function stays listening for commands from the cloud. If I click a button on my dashboard, this callback catches that message and toggles the relay on the Arduino board. For the Node 2 now, which handles our warehouse, I want to highlight a specific feature here. Edge intelligence. Notice this block of code. If data humidity is greater than equal to humidity critical, this logic runs logically on the Arduino. If the warehouse humidity crosses 85%, the node automatically turns on the ventilation relay. This happens even if the internet connection is lost, ensuring the goods are always protected. I will now show you live simulation and demo of our project. Now, For the most exciting part, the live simulation, I am using PicSimLab to simulate our Arduino Uno boards and Ethernet shields. On the right, you see my dashboard. First, notice the serial monitor. It shows the node booting up, getting an IP address successfully and connecting to MQTT broker. This confirms our connectivity layer is solid. Now I will slide the slider in the temperature gauge and temperature. Now I will slide the temperature gauge on the dashboard as I adjust the sensor's value in the telemetry is sent as JSON packet to the gauge updates in real time. We are seeing an end-to-end latency for less than 1 second. As you can see, the temperature is 28.4 and here is always the 28.4 on temperature gauge. Now I will demonstrate remote procedure called RPC. I will toggle the machine status switch on my dashboard. Look at the PicSimLab window. The red LED has turned on instantly. This proves we can control industrial equipment from anywhere in the world. Finally, let's take the automated safety. I will spike the Okay. Finally, let's test the automated safety. I will spike the humidity in the warehouse simulator. Look closely. The relay LED turns green automatically because of our cloud logic. Sorry, the relay LED turns red automatically because of our code logic, and a critical humidity alert has just appeared on my dashboard. So I will increase the humidity, sorry, above than 85. See, it will turn into red LED.
Building this wasn't without its hurdles. One major technical challenge was the MQTT packet size. By default, the Arduino library only allows 128 bytes because my sensor data was being sent as a detailed JSON string. It was getting cut off. I solved this by modifying the PubSub client header file to increase the buffer to 56 bytes, which allowed for stable data transmission. Through this internship, I have mastered several key skills: embedded C++ programming for real-time applications, network protocols, especially MQTT, TCP or IP, cloud integration and dashboard design using ThingsBoard, hardware simulation using PicSimLab to test firmware before deployment. In conclusion, this project demonstrates that IoT is a powerful tool for modernizing industrial operations. It offers a scalable, reliable, and intelligent way to manage a factory. Thank you for your time and for joining me on this project walkthrough. I am now happy to take any questions in the comment section below. Thank you very much for joining the session.